Sure, Chandra. Good evening, everyone. So,
Good evening, sir.
are you people able to see my screen?
Yes, sir, it's visible.
Yeah, thank you. So, in previous 3 weeks, we discussed how to analyze data and what are different machine learning and deep learning algorithms. So, this week, we will discuss a few advanced concepts in ML and DL area. So, this is the schedule for this week. And before going to actual schedule, in the last Saturday I mentioned regarding projects, right? You people have to submit names for group projects. I requested you people to create a Google form, but I didn't receive any form yet. So I have created one form. So just mention the project name and members, name of the members, and dataset name. That is, okay. I'm just sharing this link with you. Use this link. You can share this link with your friends as well who are not attending, but try to fill it as soon as possible. As I mentioned earlier, you people can create a group up to 4 members. Up to 4 means if you want to do your own project, you can do by yourself, but it's okay. You can form a group of 2, 3, or 4, and you can select your data set and your area and your model. And depending on the model and the data set, you can suggest your project title. I already discussed in last Saturday practice session, right? So please complete it by before tomorrow's session. Okay. Any doubt here? So actually, this is the yesterday session, day 1. So right, what is classification and what are different classification models. So right, what is a network. So here we have one input layer and one output layer. Between these 2 layers, we have multiple hidden layers. So hidden layers means we have to use one fully connected dense layer along with one activation layer. So apart from these 2, we can use dropout layers or normalization layers or max pooling layers as per the requirement. So we already tried few models with a couple of layers and we identified different accuracy levels, right, in our last lab. So now today we will discuss what are the different advanced layers or advanced models available in the research community or in the industrial area. So before that, let me introduce this ILS VRC. This is the ImageNet Large Scale Visual Recognition Challenge. It's a challenge, and every year they conduct this challenge, and most of the companies like IBM, Google, Microsoft, advanced teams from all these companies will participate. Usually they participate in this challenge, and they participate with their advanced models to showcase their networks or to showcase their work. So this is the one of the best challenge. I already discussed, right, what is ImageNet in the last session. So here you can see how year by year the accuracy increasing or the classification error is reducing. You can see in 2010 the classification error is 0.28, and in 2017 0.023. So year by year the classification error is reducing, and you can see different networks which are which which were participated and won the challenge at different years. So you can see, AlexNet, right? We already discussed GoogleNet, AlexNet, all these are the different advanced networks. So you can see in 2012, AlexNet was the inner, and this competition, they used this network. And again, this is the dataset size. The size of dataset is 155 GB, and they have lakhs of images for train set and validation set and test set. Okay, we see here they are using Stride, Max Pooling layer. This is convolution layers, right? Right? This is a convolution layer. So they are using convolution layers, Max Pooling layers, and at the end they are using dense layer. So here you can see what is the size of dense layer. It is 2048 nodes, 2048 nodes. Again, it's 2048 nodes, 2048 nodes. But here you can see 1,000 classes. So number of classes there in this particular ImageNet is 1,000 classes. So in output layer we have 1,000 classes. In 2013, ZFNet is the winner, and you can see different layers which they are using here. And in 2014, GoogleNet Inception. We can both are the names for GoogleNet only. And in 2014, GoogleNet is the winner, and we already seen the architecture, right? Again, they are using same layers: convolution layer, max pooling layer, softmax layer, and other layers means combination layers. And in the same, actually, the challenge in 2014 is very tough. You can see multiple networks are showing almost similar accuracies here. So GoogleNet is the first one, but you can see multiple networks from VGG are the on second, third, fourth, and fifth place. Okay, and one more interesting thing is you can see the placement of AlexNet and ZFNet, which were the winners in 2012 and 13. When we considering top 10. Okay, that is the level of competence. So this is the VGGNet, as we see here, the second, third, fourth, and fifth places, right? So this is the network this is the runner-up, the second position. So this is the from Oxford Vision Geometry Group. That's why we call this network as VGG. So again, whatever may be the network, people use convolution layers and pooling layers only, but the how they are using these convolution layers and max pooling layers, and how many number of fully connected layers or dense layers they are using at the end of the or after flattening the features is very important concept. We will see all these features using code as well. And in 2015, ResNet is the winner. Again, it is from Microsoft. And again, here you can see this is a Microsoft one. And here you can see there are some networks from Qualcomm as well. But if you see top 10, no Google or no Oxford VGG. So all these are the advanced networks which came in 2015, but we can see the position of here. You can see some networks, GoogleNet, VGG, and all, right? But here you can see at least on top 10 we have the previous winners. But if we see the results in 2015 on the same ImageNet, you can see no previous winners were there on the competition. Again, in 2016, again from the Microsoft, it's next one, ResNext. Previous one is the ResNet, and it is the next one. Here they have introduced this RNN network here. And in 2017, this is from the Senate, and you can see how the research goes, and you can see the accuracy levels here. During here, what is the accuracy during 2011? So in 2011, the accuracy started at 50, around 50, and in 2020, it reached more than 88. So again, this is the top 5 error rate values. So next one, are you people joined from laptop? How many of you joined from laptop? Can you raise your hand quickly? Only one? Okay, at least few people. Okay, now we have multiple options. If you want to train your own model, or if you want to create a project using DLL, we have multiple options. We can directly download pre-trained models and we can use them, or else we can download pre-trained, sorry, untrained structures or standard structures. For example, if you want to train the Google Net structure is already there, right? So if you want to download the structure and train with your own images, you can do that. If you want to create a project with pre-trained Google Net, we can do that. If you want to develop your own architecture, we can do that. So if you want to download pre-trained or untrained models, we have to import those models from PyTorch Vision. So for that, first open your Spider, quickly open your Spider and let me know once you are done. Once you have your open Spider environment, you can directly copy paste this command. I have already pasted in the group chat. You can directly execute here and check whether you have this touch vision or not. If you face any issues or the tool says there is no module called touch vision, you can directly install it using pip install touch vision. Let me know if your people are done with this first step. This is very important one. Are you people done with the first step? Are you people facing any issues during pip install? Can you people raise your hands once you are done? So you can see here, all the standard models are already there in this Touch Vision, and you can directly import all these models here, and you can select your model, whichever model you want, and you can mention here whether you want train model or not. If you don't want train model, if you want just model, if you want to train your with your own data, you can delete this part here. Like you can import like this. If you want the train model, if you want to use this train model in your project, you can add this flag here, whether you want pre-trained model or not. Okay, at the end of this one, you can directly use this eval command and you can print that. It will show all the things which are there in that particular model. So here you can see all the things. This is ResNet, right? So now you can compare with the architecture of ResNet here, which I will open that part. Give me a second. ResNet. This is the ResNet, right? So you can compare with this part. This is the ResNet and this is the architecture. Here we are seeing the same architecture here. What are different layers? You can see different layers, layer one. So here it is the layer one, here it is the layer two. So like that, we have all the layers here along with the different kernel sizes, how many kernels we are using, what is the size, what is the stride value. We already discussed, right? What is stride, what is kernel size, what is filter size, all the things, right? So here you can see all the values. What is the different values in layer 3, layer 4, like that. For each and every layer, we have all the information here. So again, this is the pre-trained model. We can use the weights as well. Any doubt here? So not only this one, we have other layers as well. Sorry, other networks as well. We can import all the networks and we can see. I will paste all these commands. The command will, sorry, in chart. So you can directly type one by one and you can check. So like this is the one I have already pasted. So you can enable one by one, and you can check how many layers are there in AlexNet. If you want to check this one, you can directly use this AlexNet here, and you can run this one, and you can see the structure of AlexNet here. We already discussed, right, how multiple layers are there in AlexNet. So you can see all the things here. Convolution layer, ReLU, max pooling, again convolution ReLU, max pooling, convolution ReLU, convolution ReLU, convolution ReLU, max pooling. Okay, this is the convolution one. After that, we have platen layer. Once we have the platen layer, we have linear layers. Linear layer means fully connected or dense layers. Okay. Any doubt here? I will give you a couple of minutes. You can check each and every network here. Simple thing is, you can uncomment out each and everything, and you can run this one. And you can check corresponding structure. This is VSNet. You can see again the same structure. You can see different activations, different kernel size, different stride values, all the things. Why I'm showing all these things is, you people know now, you people can understand all this terminology, right? What is a convolution layer, what is activation layer, what is pooling layer, what is normalization layer, all the things, right? What is ReLU, what is softmax, all the, you can now, you can understand each and every terminology. What is padding, what is stride, all the things. So now you can easily understand how the people are, how the companies are developing their own networks. Okay, whatever may be the network, whatever may be the company, irrespective of all these things, each and every person or each and every network should use only set up layers. How we are arranging those layers, and how we are changing the features, and how we are optimizing the layers is the matter. Okay, if you are done with all the networks, let me know. Where are your hands? Once you are done with all the layers, just raise your hands. I will count and I will proceed further. Do you people have any doubt here? This is the first step. We are not here. We are not using the networks. We are just analyzing the structures of the network. In a script, we will see how can we use the pre-trained models. If you have any doubt here, you can ask me. Okay, meanwhile, let me discuss the other part. After that, we will discuss couple of other scripts as well. So day two concept is object recognition. So there is some difference between image classification versus object detection. So image classification means, for example, if we have a image, we have to classify what is the class of that particular image. For example, whether it is a dog, whether it is a cat. So we have to define, or we have to provide one label or one name to the entire image, irrespective of how many objects are there in that image, or how many uh, animals are there in that image. Irrespective of all those things, we have to classify, or we have to provide one name. Okay, any doubt there? No, right? We are already doing, whether it is a cat, whether it is a dog, whether it is a pencil, whether it is a cup, all the things, right? So, but in such scenarios, or in such classification scenarios, even though there are some small object, for example, if you have a if you have an image with a big cat and a small dog, we have to classify that image as a cat by ignoring the small dog, right? Like that, we don't have option it has a cat and it has a dog. So if you want to do the such things, we can go for object localization or object detection algorithms. So object detection or object localization algorithms means, instead of providing one single label or one single title to the image, we can provide multiple titles or multiple labels depending on the areas. So instead of taking entire image, we can take some part of the image and we can assign one name to that particular region. For example, if you have a cat and a dog in the single image, you can select the area of the cat and you can label that area as a cat, and you can select the area of the dog and you can assign dog label to that particular area. So like that, you can select different parts of the image and you can label different names. Okay, so that is a simple difference between object detection and image classification. Any doubt here? So coming to algorithms for image object detection, we have CNN family, which is specifically regional CNN family, and YOLO family. You only look once. Okay, so CNN, RCNN is a very good one, but it's very slow and it concentrate on only one particular area of the image. We see here, instead of concentrating on entire image, we can take one part of the image like this, and we provide one name to this particular image. And depending on that name or label, we will extract that particular area and we will process this particular image instead of considering entire image. Okay, and we name this is one with one label, and we process depending on that label, whether it is a person or a aeroplane or a TV monitor, depending on the regions. Okay, it's again derived from the standard CNN model, but only difference is, instead of considering entire image, we consider one particular region. But here, as here we extracting the regions, multiple regions, it will take huge amount of time. That's why it's very slow. To increase the speed, researchers developed a couple of algorithms, fast RCNN, faster RCNN. We have multiple versions here, but again, the problem is the speed is increased a little bit, but all the algorithms in this particular RCNN family are slow. So here you can see again they are using this uh, area extraction or RY, region of interest, right? So they're extracting this particular area and they're applying some convolution layers on this area, and they are trying to extract this output label as well as B box. B box is nothing but bounding boxes. So they are separately processing both the things, and they increase the speed, but still the problem is the frame rate is very low. And faster RNN is the another one. Here they are using the same thing, but they are first extracting the feature map. From feature map, they are trying to extract the class pair as well as the ROI pooling. So they have both the separate what we can say, both two separate channels. Okay, but the problem is again it's slow one. You can see two separate modules here, a regional proposal network and another one is the past CNN. So they are using this network and they are using another separate network for regional proposal where the particular object is. So they are using two separate networks. So next one is the YOLO family. As I discussed earlier, RCNN techniques concentrate on one particular region and they are slow. But YOLO framework takes entire image and this will separate into two channels. One is the bounding boxes plus condenses, another one is the class probability map. So they use two separate channels and they try to identify the bounding boxes depending on the this class probability map. We will discuss how all these things will work in our scripts, but it's very speed and we can process up to 45 fps. You know, right? What is fps? Frames per second. Means we can track an object even though the frame rate of the video is 45 seconds, sorry, 45 frame rate. Any doubt? As we have fast CNN, faster CNN in CNN RCNN family, here we have YOLO version 2, version 3, 4, 5, 9000, like that. We have multiple versions and version by version the speed is increasing. So again, let's go back to spider environment. Do people have any doubt here? If people don't have any doubt, we will see how we can download the models and use in our scripts. For example, uh, sorry. So here we have this ResNet 50. So you know, right, what is ResNet? So here I'm downloading this ResNet and its corresponding weights. You know what are weights, right? What is the weight? That's why I have placed the first slide here. So here you have W1, W2, W3, all these things are weights, right? Along with this bias value. So these are the tunable values. Once the meaning of training is tuning all these values in order to get correct classification here. So we have to tune all these values. After training, we will get the tuned values. So here we have these weights here means we have the tuned weights here. And the architecture is this one. Okay, now we have to now import this architecture and this train values and we have to load these train values. After that we can directly use our own images. You can directly download your own image and we can apply and we can classify. You know, right? ResNet 50 is a classification model. So you can directly run this script and you can see how this will works. You can see here I am importing this ResNet and ResNet weights from the touch vision itself, and here I am loading. You can see weights is equal to, these are the weights, right? So I am directly importing these weights and here you can print and see how the model is and you can transform the weights and you can load your image as well. If you have image, if you want to load a image, you can directly use read image and you can load this image and you can check what is the class here. You know, right? Prediction one. So you can directly go for this prediction and you can check for the maximum value. Why you are taking maximum value? You know, right? The architecture of the network. If you want to check that one, let me open another PPT. Okay, if we consider here, for example, here if we have 4 classes, so we will get different values for each and every class, right? For example, here it may be 0.25, 0.3, 0.4, and 0.5. So in that case, we have to identify which is the maximum one, right? So here it is 0.5 is the maximum, and this is the predicted class. So we have to identify the maximum value, and we have to identify that particular class, and we have to set that is the predicted class. So we are doing the same thing here using program. Here what we are doing, we are first taking the prediction from the model. So here you can apply multiple images or single image. Here I'm taking single image as a batch, and I'm applying this batch to this model. Okay, and I'm taking the output of the softmax. Softmax is nothing but your output layer, right? And in that output layer values, I'm taking all the items, and here I'm taking the maximum. Maximum means nothing but what is the maximum value, argmax. And that from that argmax, I'm taking the item, and here I can see using the class ID, I'm taking the prediction score. Prediction score is nothing but previously we discussed, right? 0.25, 0.3, like that. So using that one, we have item and the prediction score, as well as we can take the name. If you want to take the name, we have to go for what is the, again, go back to this one. If you consider this particular, okay, let's consider this one, and let me quickly, we have multiple things here, don't confuse between all the things. So let's say it's a cat. In the same way, let's consider another thing, it's a dog. Okay, again we have numbering system, right? So here it is the, let's say this is the 0th node, and this is the first node. Okay, and again here we have some prediction probability. Let's say here we have some probability, our prediction score is 0.25, and let's say here it is 0.3 or 35. So now here you can see multiple things. So here it is a node ID is nothing but here the 0 is the node ID or class ID, and this is the class name. So ID is different from the name, and this is the score. We have multiple things, right? So first we have to identify what is the maximum score. Depending on the maximum score, we have to identify what is the corresponding ID here. Depending on the ID, we can directly extract what is the class name here. So we required all the three things, right? So here we can see all the things. First, we are identifying what is the maximum value, and depending on the maximum value, we're identifying what is the class ID, and using the class ID, we can identify what is the class name, and we are trying to print this. Any doubt here? I'm just copy pasting into group. Why it's not allowing me? Quickly run here, and meanwhile you can see the results. I will paste. You can see here it's a grasshopper with confidence or score 37.9. Any doubt here? You people can unmute yourself if you have any doubt and let me know. Sundara, why it is not allowing me to paste? Do you have any idea? Sindura, are you there? Can you people hear me? Can anyone confirm?
Yes, sir.
Yes, sir.
Okay, thank you. So meanwhile, you people can do one thing, just download one image from the internet. You can download your own image and you can run and check. Here I have downloaded a couple of images. You can see. Classes, week 4, day 1, 2. Okay, I think you people can directly download from the chart. I have directly uploaded the file. So here you can see here we are not training any model. We are directly imported the pre-trained model, which is already there. We know this network as ResNet from the Microsoft. So we are directly downloading this along with its weights and we are using. Okay. Here you can download any image like this. You can directly go to Google and you can download one image and you can directly you can search for some dog or cat, whatever it may be, grasshopper, whatever it may be. You can directly download and place into your local drive. So here I have my script. Just below the script in the same folder, you can place your file and you can directly use the same name here. You have to use the name here. Okay. and you can simply run this one and you can see the results like this. If you face any difficulty, let me know, or if you are done with the script, you can tell me. So this is the image I have used, and you can see the corresponding result here. See this one, right? It's download.jpg. I'm using the same name previously, and for that one, it's showing it's a grasshopper with confidence level 39, 37.9. So here all the things are floating ones. If you want to quantize a model to U into 8, you can directly go and download. Instead of, you can see the difference here. Here we are directly downloading the touch models less than 50. Instead of using touch models, we can go for the quantized models. And inside quantized models, we have all the models. Again, we have ResNet, AmazonNet, GoogleNet, like AmazonNet means AlexNet, right? So we have all the networks. We can directly download here, and we can download the quantized weights. And you can, in the same manner, we can use the same thing and we can train. Sorry, we can predict. We are not training. Keep that in mind. We are using the pre-trained models. See here, and you can see again, it's a grasshopper with level here. But as here we are using the quantized model, the accuracy will be reduced, right? So you can see the reduced accuracy here. When you are using complete model or floating model, the accuracy is around 38. When we are going for quantized model, it's 35.5. But the main advantage here is we can reduce the size, because instead of using floating points, we are using the inches, U in 8. Any doubt here? So I will share this script as well. Are you people able to download the script, the previous one? Are you facing any challenge? Can anyone unmute? Anyone download it? At least one person? Are you people following me?
Yes, sir.
Are you able to download? That's why I requested you people to log in from the laptop. Any doubt here? Once you people done with the this classification, we can see some semantic segmentation model here, and you can see the results as well.
Sir, voice is not audible.
Sorry, now is it okay?
Yes,
Yes,
sir.
sir.
Okay, sorry. Actually, I'm talking a little bit low because I have some throat infection. What happened? Okay, here it is opened. It got closed. Sorry, something went wrong with my Maximize. Okay, this is the one. So this is the output of this particular program. So here I'm loading this one, this image. Let me quickly open this one. So this is the image I'm giving. You can see, right? It's download one. You can download any image and you can provide as input to this model. And this is semantic segmentation model, right? Means it will identify the object as well as it will provide the location of the object. You can see the location. Okay. Along with you can see what is the this particular thing is. Here you can see it's a dog, right? So you can identify a dog here. Any doubt?
No, sir.
I will share this script as well. The last one is the sorry. We already discussed past RCNN, right? So I will run that one and I will show that result as well. Actually, it should be open in different window, but let me close all of this. Yeah, this is the output. So here you can see we can easily identify the location of the this particular object along with the name. You can see here we can see dog, right? So we are able to identify what is this object and what is the area along with the bounding box, right? So this is nothing but object detection. Okay, let me quickly upload all these scripts to you. You people get the point, right? Sometimes you have to concentrate on the model training. Sometimes you have to concentrate on some other things apart from the model training. So if you want to concentrate on model training and the main motto of your your project is to develop optimized model, then we have to create your own model and you have to create your own data set and you have to train your own model, okay, in order to provide optimal results. But in some cases, uh, your concentration of the project or the concentration of your project may be different, and you have to concentrate on some other part apart from the model training. In that case, you can directly download these retrained models and you can use for your purpose. And you can, it's very easy and straight away process, right? You can directly import and use. Okay, nothing to do with the data processing, pre-processing, or nothing to do with model creation, training, right? So you can directly import and use, and you can concentrate on other parts of the project. So you have to decide whether you have to create your own model or whether you have to use the pre-trained model. Okay, I will give you a couple of minutes here. You can open all the 4 scripts and you can run and let me know. Please raise your hands once you are done with the process.
Sir, can you scroll down the cursor one?
Scroll down cursor. This one.
Yes, sir.
I have already shared this script with you. Why are you taking screenshots? You can directly go here and you can see all the scripts right here. Are you people able to see this one? I have uploaded all the scripts. You can directly click here and you can download.
No, sir.
No?
No, sir.
Why I have already uploaded, right? Then what you people
Yes,
are
sir.
doing?
It's uploaded, sir.
Are you people able to download?
Yes, sir.
Yeah, that's fine.
Sir.
Okay, please download and try to run it. Only thing you have to do is just go to internet and download at least one image. Okay. And just rename it and place it along with your script. And here you have to use the same name. I have uploaded 4 scripts. At least try to run couple of them and let me know if you face any difficulties. It's very small script, right? You can directly download using one line and you can directly apply your image and you can directly identify what is that particular image is. So if you have a big project or big idea, you can use this. For example, if you want to list out all the objects which are there in one image, what we can do, one video. You can load entire video and we can split into frames and you can use this logic. In loop, you can use this logic and you can identify all the objects and you can add to a list. At the end of the loop, you can list out all the things. Okay, these are the different items which are there in the video and this is the time. You can take the frame number and you can convert into time and you can mention, okay, these are the different items which are there in the image at this particular time steps. Like that, you can list out all the things. One more thing, if you want to train these use networks on your laptops, it will take couple of months to couple of years. So don't try to do that. Three people done with at least two of the four screens. Yes, please raise your hands. So next one is the concept. So first we discussed last week we discussed how to train our own models. So just now we discussed how to use the pre-trained models. So between these two we can do another thing. Means we have two parts in CNN, right? First one is the convolution part and second one is the fully connected layer. So we can freeze the convolution part with the pre-trained values and we can retrain the fully connected layer. I'm getting some messages. So should download the yes. For this use pip install touch vision. Same thing. Okay, this is the third method. Means we can use our own models or first method is that one. Second method is we can use pre-trained models. Third method is the mix of both. We can use some part of the pre-trained models and on top of that we can train with our own images. Okay, for that what we have to do, you know the architecture of CNN, right? Again, I'm opening the last week PPT and here you can see what is CNN. Okay, somewhere here. So here you have, right? So this is nothing but your convolution layers and this is fully connected layer, right? So what we can do here, you can use the pre-trained masks here. Means this part is pre-trained one and we have to train our own fully connected layers here. So we are using the convolution layers or pre-trained convolution layers and we are training fully connected layers with our data. Okay, this is the third part. Means we are using some part from the pre-trained network and we are training the remaining part. So for that, what we have to do, simply we can download the network like this. We know, right, how to download. We have TensorFlow. Inside TensorFlow, we have the VGG16 and we can directly download that. And inside that, we have to freeze the output layers. You can see we are freezing here. Okay, base model layers. Here you can see we're disabling all the trainable values. On top of that, we are adding we are flattening and we are adding our own dense layers here, means fully connected layers. And now we are setting the compiled options and again going for the training. You know this part, right? How to set compile options, how to go for training, what is epoch. We know all these things. Okay, but the only thing is, instead of directly taking our model, instead of using our own convolution filters, what we are doing, we're directly taking the base model as VGG16. Okay, in VGG16 model, we are freezing convolution models. On top of that, we are adding our own dense layer. Same thing I just explained here, right? We are taking, this is VGG, let's say this is VGG16. So we are taking this VGG16 and inside this VGG16, we are freezing all these things. Means we are not changing anything here. But what we are changing, we are adding our own dense layers or fully connected layers, and we are trying to train here. Okay, you can see the same thing here. Clear? So for that, how can we proceed? You can see here, I will, if you want to do this project, or if you want to run this one, first we have to download this. So you can directly use this link and you can directly download the zip file. Okay, and you have to place the zip file here. Here you can see the zip file, right? I have downloaded and I have placed it here. So first you have to do that. Once you have this zip file, you have if you have zip file to extract into local or some particular directory, we have one module to access the zip. So we have to download the zip file, means we have to import this zip file module, and using the zip file module we can directly extract into particular folder. So here I'm extracting into temp. Okay, so inside this folder we have multiple subdirectories. You can see train, test, cats, dogs, all the things, both in training and testing one. So you can see all the things and we have to add all those things. Okay, now we have set up for all these things. If you don't want to process with all these things, you can manually do this. How can we do that? We can directly extract this. You can create a folder here. Let me open here. I will try to explain. Okay. What we are doing is, here we have a folder name as dataset. We can take any name. Inside this we have two folders. Okay, first one is the text and another one is the train. Instead of test you can use validate as well. So here you have two folders, right? So again, inside both, in test we have to add all the classes. For example, we have two classes. You can use cat class, and another one is the dog. Okay, we have to use the same structure in train as well. We have to create two folders, not only two, depending on how many classes you have. We have to create all the classes here, and for each and every class we have to create one folder. Again, inside these folders we have to place the corresponding images. So this will be the your data set. This is the standard structure. Okay, we can manually do that. Okay, otherwise you can directly add using the script. Okay, you can see here I have created a directory. In test I have cats, sorry, in train I have cats and dogs. In validation also I have cats and dogs. Okay, here I have major two folders inside this. First one is the train and validation. Instead of test here, I have used the name validation. So both are same. You can use this part of code to do that using script. Otherwise, you can do that using manual steps. Any doubt? After that, if you want to see what are different images there, you can use a subplot here and you can plot some images from both testing and training. Okay, you can see here we are plotting two different subplots. So this part is not necessary. If you want to check, you can go for visualization, you know, right? Data pre-processing and visualization. After that, we have to use image data generator. What is the advantage of data generator? We already discussed, right? We can go for augmentation. What are the different parameters in augmentation? We can rotate image, we can change the width shift, we can change the height shift, we can change the seed angle, we can change the zoom range, we can use horizontal flip, vertical flip. We have different options, right? We already discussed. If you forget, we can directly go to this slide and we can directly check here. What is data augmentation? Here it is. So you can go for all these things, right? So here we can apply some of them and we can go for data augmentation here. Okay. After that, we have to go for scaling, right? So again, as it is image data, we can directly scale by dividing with 255. Okay. Once we have this data, we can directly, here we have two classes, right? So class mode is binary and we can generate train dataset and test dataset. As we have data in directories, we can directly take it from the train directory and test directory. We have the names here. We have already provided the names here, right? What is test directory, what is train directory. So these commands will load the images from this directory and place in these generators. Any doubt here? Remaining part we have already discussed. We have to first import the base model, which is VGG16, or you can take Google Net, AlexNet, you can take any network. Okay. Again, we have to define which kind of weights we required. Here I'm taking the weights which are derived from the ImageNet. Okay. After that, we have to freeze few layers. Here you can see trainable false. If you are not doing this during training process, the weights of the convolution layers also change. That process may corrupt the entire knowledge of the VGG model. That's why we are first freezing here and we are retraining for our own models. Again, what is the advantage here? If you consider VGG16, the basic VGG16 model is trained for 1000 number of classes, right? So if you are classifying an image among 1000 categories is very difficult and the accuracy may be very less. But if you are using or if you are classifying the image between only two classes, okay, it will be very easy, right? That's why here we are reducing the number of classes from 1000 to 2. Here we have only cats and dogs, right? So our own purpose, we are using the pre-trained model, but we are increasing the accuracy or more knowledge of the model by taking only two classes. We are ignoring all the remaining classes. Means we are simply optimizing this model for our application. And here, here you can see, here I'm adding layers. Here it is a flatten layer, right? After that, I'm adding dense layer and dropout layer, again the dense layer, and finally sigmoid. Why I'm using sigmoid here instead of softmax. It's binary classification, right? If you have multi-class, we have to go for softmax. As it is a binary, we can go for sigmoid. And you can create a model, you can set the compile options, and you can train your model. One more thing here, don't use a high number of epochs. It will take huge amount of time. I have only 10 minutes. I will change this to 1. The accuracy may be less, but it's okay. I'm just running the script. Do you people have any doubt here meanwhile? Here you can see some statements. Found 2000 images belongs to 2 classes. Found 1000 images belongs to 2 classes from these 2 generators. Here we have used 2 generator, right? Train generator and validation generator. So from this one, it is showing for train generator means inside the train folder, it found 2000 images from 2 classes. Inside this validation, it found 1000 images from 2 classes. Again, here you can see how slow it is. I'm using only one epoch and it will take a couple of minutes. Meanwhile, I will share the script. With you. Here it is, right? Okay, you know, right, how to run this script. First we have to download this. First we have to go to this location and you have to download this and you have to place this zip file just in the same folder and you have to run this one. Please download all the scripts before closing the meeting. only 35 now. Okay, let it be trained. Meanwhile, if you have any doubt, you can ask me. Now you understand all the three ways, right? Meanwhile, let me quickly open that one as well. Okay, it's consuming my entire RAM, I think. I'm repeating this again. This is the Google form. You just open this one and you can provide your title here. Like you can provide any title like cancer detection using 4-layer CNN. Okay. After that, we have to enter what is the dataset name. Like you can enter any dataset. I'm not sure the exact name, but you can take, for example, experts cancer data set with some 20K images. Like this, you can mention. Okay. After that, which kind of algorithm you want to use, you can use CNN. Okay. After that, you can mention what is the size, whether 2 or 3. If it is 2, you can mention 2. After that, you have to decide who is the team leader. Okay. You can mention some XYZ name here, and as it is 2, you have to add one more number. Again, some ABC. So 2 names here. You can left these 2 blank because only 2 members. If you have any questions, you can ask me. If you have any comments, you can ask me. At the end, you can directly submit. Okay. By the end of tomorrow, I need all these things. Once you submit all the data, I will get a sheet like this. Sorry, people are asking questions. I'm getting like what you are getting. What is the script? Right. Okay. Who is this one? Yeah, Manoj Kumar. Okay, it's good only, right? You are getting the class name as well as the accuracy, right?
Yes, sir. But there's no plot coming.
For this one, do we have plot in that one? This is just classification, right? You are running just classification model. You are not running detection model. That's what I mentioned, right? That's why I have give all the scripts with you, and I have discussed this part here.
Okay, sir.
Where it is, yeah, this is classification versus detection. Classification means you have to say what is the image. When I'm giving one image, for example, if I'm giving a dog image, you can directly say, okay, this is a dog. If you are saying it's a dog, the entire image related to one dog. Okay, if you are going for detection, you have to identify, okay, this is the area of the dog and this is the bounding box, so you have to provide that one. So you have another script, right, with underscore d. Instead of c, you have d.
Yes, sir.
So you can run that one and you will get the one. You will get some bounding box.
Okay, sir. I'll try it.
Yeah, you can use the same image or you can go for different image. You can just run it. That's it.
Okay, sir. Thank you.
Okay. So we are running out of time. You people already downloaded the script, right?
Yes, sir.
Okay, cool. Tomorrow also try to join from your laptops. Chindur, are you there?
Yes, sir.
Yeah.